Time for a review on everybody's favorite subject, logarithms. So if we want to rewrite log of 12 into a sum of logs, we want to remember how to expand a logarithm. And we can expand a logarithm that has its terms being multiplied into a sum of logs. So if I think about what the factors of 12 are, I know that 12 is the same as 3 times 4, but if I want to use only prime numbers, I can think about 12 as being 3 times 2 times 2. So now remember, with multiplication, we can break this up into a sum of logarithms. So this would give me the log of 3 plus the log of 2 plus the log of 2. And I could rewrite this as the log of 3 plus 2 times the log of 2, since there are 2 of them. Now, if you broke this up as the log of 3 times 2 squared, you should also get the same answer. Because remember, if we have an exponent, so 2 squared, the exponent moves in front of the logarithm. So similarly, with number 8, if we want to simplify log base 2 of 2 cubed, you can remember that this 3 can come out in front of the logarithm. So we have log base 2 of 2. And log base 2 of 2 is 1, because 2 to the what power gives you a 2, 2 to the first. So then 3 times 1 equals 3. You can also remember that if the base of the logarithm is the same as the base of the exponent, the answer is just the exponent. So we could pretty much just look at this problem and know that the solution is 3. For number 9, we need to remember about condensing logarithms. We cannot solve a logarithm if there's more than one logarithm on one side of the equation. But we do know how to condense logarithms, so we can turn 2 logarithms into 1. So since these 2 logarithms are being added together, we can condense them using multiplication. So we'll have log base 3 of 4x times 2x, which would give us 8x squared. And that equals 2. So now we need to get rid of the logarithm, or do the inverse. And so to get rid of the log, we want to exponentiate both sides. And I always want to exponentiate with whatever the base of the logarithm is. So we need to exponentiate both sides with a base of 3. So that will give us that 8x squared equals 3 squared, which is 9. And now we just need to solve this problem. So if we divide both sides by 8, we have x squared equals 9/8. And we need to take the square root of that. So we're going to get x equals, and remember when we're solving and taking a square root, we need a plus or minus. So the top will be 3, and the bottom will be 2 root 2. And we should rationalize our final answer. So we have x equals plus or minus 3 root 2 all over 4. For number 10, if we have 12 is less than negative 4x, which is less than 16, I can solve this all at once by dividing everybody by negative 4, except we do need to remember that when we're solving inequalities and we divide by a negative, we need to flip the sign. So we end up with negative 3 is greater than x, which is greater than negative 4. And usually when we write the answer, we put the smaller number on the left side just so it kind of follows in the same order as a number line. So I would probably want to rewrite the answer as -4 is less than x, which is less than -3. And that kind of makes more sense because this is saying that x is in between -4 and -3. Now, number 11 is more of a thinking type of problem. When is 4x plus 4 over the absolute value of x plus 1 greater than 0? So we need to remember, when are fractions greater than 0? Well, fractions are going to be greater than 0 or positive if the top is positive and the bottom is positive. That would give us a positive number. Fractions are also positive if the top is negative and the bottom is negative. However, in this case, we have an absolute value in the denominator, and absolute values are always positive. Therefore, 4x plus 4 also needs to be a positive number or greater than 0 for the whole entire fraction to be greater than 0. So we really have a pretty easy problem to solve. We just need to solve 4x plus 4 is greater than 0. So we get 4x is greater than -4, so x is greater than -1 as our answer. But what we want to be careful and do is check to make sure that our answer makes sense with our original problem. So if I plug in a number that's greater than -1, is that going to be true? Well, if I plug in a 0, I'm going to get 4 divided by 1, which is greater than 0. It's great that our answer ended up to be x is greater than -1 and not greater than or equal to -1, because if it was, we would have to exclude the -1, because if I plug -1 into the denominator, I would get a 0. So if you end up with an answer like this would be a case where you would need to go back and check, and then you would notice, oh shoot, it can't be equal to -1 or else the denominator would go to 0. So I need to make sure to get rid of that equal to sign and just use x is greater than -1. For number 12, we want to use our background knowledge of trig graphs to answer this question. True or false? Is the sine of point 2 less than the cosine of point 2? And this is a question that can be answered without using our calculator, if we can just visualize what the trig graphs look like. On the AP test, you'll be able to use your calculator for a portion, but a portion of it will be non-calculator. So we need to get used to being able to answer some questions without using a calculator. So if we kind of imagine, or if we draw what the trig graphs look like, I'm going to draw the sine graph real quick. The sine graph starts at 0, at pi over 2, comes up to 1, at pi it goes down to 0, at 3 pi over 2 it's down at -1, and at 2 pi it's back at 0. And then if we draw the cosine graph, we want to remember that the cosine graph starts up at 1. At pi over 2, it hits 0. At pi, it goes down to -1. 3 pi over 2 comes back to 0 and back up to 1 at 2 pi. So now we need to imagine where point 2 is. So if we think about point 2 and pi over 2, and maybe easier to think about pi. In decimals, pi is 3.14. So pi over 2 is about 1.57. So point 2 is pretty close to 0. So up here somewhere would be the value of point 2 for sine x. And up here somewhere would be the value of 0.2 for cosine of x. So if we think about it, at sine x, we're just kind of coming up from 0 when we get to 0.2. And at cosine of x, we're just coming down from 1. So we can probably say that this statement is true because at 0.2, our value would be closer to 0 for sine, and for cosine at 0.2, our value would be closer to 1. For number 13, we want to find the tangent of the angle interior to y equals 2x and y equals 3x. So first we're going to find the tangent of the angle to y equals 2x. So I think it's pretty smart to draw a picture. So if I want to draw the line y equals 2x, I know that it intercepts at 0. And the slope tells me that I go up 2 and over 1. So if I draw that line, I want to find the tangent of the angle that is interior to y equals 2x, which would mean this angle. So if I draw a triangle and attach it to the x-axis, draw a better triangle, there we go. I know that the opposite side of the angle is 2 and the adjacent side is 1. Therefore, the tangent of that angle, we'll call him theta, is 2 over 1 or 2, opposite over adjacent. So similarly, I can't say that word right now. For y equals 3x, so if I draw y equals 3x, we know that we have an intercept at 0. We'll go up 3 over 1. So we want to do our triangle, and we know that the sides of our triangle are 3 and 1. We don't need to bother finding the hypotenuse because we're doing the tangent anyways of our angle. And we'll just call this angle phi to keep it separate from theta. So the tangent of phi, opposite over adjacent, 3 over 1 equals 3.